Welcome back to Computer Science 248, Operating Systems Programming. This is Lecture 12 on shell scripts, more features of shell scripts. We've looked at shell scripts, we've written a whole bunch of them. This lecture is based on Chapter 13 of our textbook. And the two main things that we will look at within the area of shell scripts is signals and input-output redirection. Okay, so signals first. Let's take a look at what signals are. They are software interrupts sent to running programs. You might ask, well, what are software interrupts? Interrupts are just short messages, and then they can be software or hardware. Hardware signals are usually sent on an actual physical line, such as every time you hit something on the keyboard, excuse me, a hardware interrupt is sent. So this is a big area, not something that we can really cover, but you can, for example, take a look at this Wikipedia article on interrupts and see that basically an interrupt is a signal to the CPU or the processor, and it can be emitted using either hardware or software. So hardware, think keyboard, mouse, things like that. Software, there's all kinds of interrupts that can cause software interrupts. They can actually be special instructions that are executed by the CPU that generates an interrupt, or they can be actual signals like we're going to discuss. And that's really not, signals are not really discussed in this Wikipedia article on interrupts, but this gives you a background on what interrupts are. Okay, so the most common one, that is the most common signal that we probably have used, is the Control-C keyboard interrupt. And the default action is the termination of the foreground process. So we can simulate this. Let's say we run a program that's taking too long. You can stop it using Control-C. So this is a simple example. You say sleep 1000. You could have it sleep for a really long time, and you wouldn't want to wait. Chances are you'd want to stop this. And so I'm going to hit Control-C, and it's stopped. Okay, so when you hit Control-C, it's the same as sending a signal to the sleep process. So Control-C is received by the through the keyboard, from the keyboard by the system, and then the bash shell is what actually generates the signal. So another way to do this is to do the sleep and then open up another terminal. I'm just going to open up another terminal. All right. You just change. Okay, there we go. Hope you can see that. So that sleep process is running. I've opened up another terminal, and I can say PS. I think AF is probably enough, and we can figure out the process ID of this sleep process. There is 3931, and so what I can do is say kill, and I believe it's the signal number 2, and we'll see the list of signals soon. And I'll send this to 3931, and you get the same effect. So and we'll see this later, the kill command, all it really does is send a signal. And in this case, I sent signal number 2, which is the same as the signal that you would be generating if you hit Control-C. So Control-C by itself is not actually the thing that stops something. The Control-C signal is received by bash, and then bash kicks off a signal to this foreground process. Okay, so we'll take a look at all these details. So most of the time we think of Control-C as directly acting on the foreground process. Actually, it seems that way, but it's actually not the case. Control-C is received by bash or the operating system, and then the operating system sends off a signal. So there's many signals. Control-C is just one of them. So here's a list. Signal number 1 is the hang up signal, and we can try that out. And we've used the no hup command to try to prevent hang up. And what that does is actually just blocks the signal number 1. So notice that the purpose of SIGHUP is to inform a process that when the user or the owner of the process logs out, the process should be terminated. Okay. Signal 2, like we just saw with the kill command, is the same as the SIGINT, which is Control-C. So this is generated when the user presses Control-C, the operating system sees that there's a Control-C and sends the foreground process SIGINT signal. There's also signal 3, there's a 9, we'll look at that later. And there's a whole bunch of other things that we will get to. In this chapter, we'll only see a few of them, and then we'll see it again when we start writing C programs. Okay. So bash programs or shell scripts written in the bash shell programming language can intercept signals using the trap command. So trap is a command, and it can, upon receipt of a signal, it can execute a command. So you can either say no command or just leave it empty, which is often what happens, or you can put in a specific command that will get executed when a signal is received. So here is a simple example, but before we get to here, let's try a few simple scripts that I've set up. So first one, I hope you can see this. All this does is it says sleeping, sleeps for 2 minutes, 120 seconds, and then says echo, I'm awake. So if you run this, 12.01.sh, this just sits around, and then in the meantime you can figure out using the ps command, and I'm going to have to resize this window. Okay, here we go. PSAF. We get our sleep. It is 3938. In this case, we can just hit Control-C and we can kill it. Or if you run this, of course, next time we will have a brand new process ID. Now it's 3941, and I can say in here, once I resize this, okay, I can say kill -2, same as before, and here's the process ID is 3940 is our process ID of that shell script. Oops. Oh yeah, that doesn't kill it, so we have to use the process ID of the sleep command itself, and sure enough we killed it. The reason we know that we killed it is that if you were to cat this, we would we see that the very last line didn't get printed over here, meaning that the reason it didn't get printed was because we killed it. Okay, it's not because it just 2 minutes had passed. Alright, so that's a very basic shell script that it's prints out a message and then does some work. In this case, it's not really doing any work. This is just going to sleep for 2 minutes. The next one, what this does is the same thing as before, except that it's going to trap and not execute a command if it gets a signal 1, 2, or 3. So let's run this. Okay, so this time around it's sleeping. Let's bring up our shell, our second shell. Okay, and we'll do a PS because it's a completely different instance of that program, instance of sleep. So this, the shell script is 3945 and the sleep is 3946. So let's try to kill it. -2, 3946. And notice it doesn't work. Why is that? Because we trapped signal 2. We also trapped signal 1. So if you were to, for example, do this, kill -1, you can't kill it. Try kill -3, that doesn't work either. So what can you do? It turns out there's a bunch of signals that we haven't blocked. And this would be one case where you can try some of those other ones like -15, and it killed it. So we terminated the sleep process, and then the next line did get executed this time around. Okay, so another way to use this would be to, for example, say no hop. We used that before, and we'll run the 01 script, which doesn't have a trap, does not have a trap, right? And then we will get our other terminal. All right, let's clear this. Say PSAF. Here we see our sleep. We can say kill -1, which is the hang up signal. 3951. It's the sleep process. And of course nothing, because we executed it with no hop. Okay, so that's why this time around it did not work. If you say kill -2, 3951, then of course we are able to kill it. Let's try that again. In case you didn't believe me, let's try it like right away. It's not PSAF, find the process IDs, 3956, kill -2, 3956, and of course it does work this time. So -1 will not work. That's a hang up signal, will not work if you use no hang up, of course. But you can try some of the other signals. Okay. So that was script 01. You can run it with, so let me just cat it again. 1201. That didn't have a trap command, but you can run it using the no hop command, and it'll ignore signal 1, but it cannot ignore the other signals. To ignore the other signals, we have to use the trap command. So trap, this is like running no hop, but also it'll also block, in addition, it'll also block signals 2 and 3 as well. And you can have any number of signals. So let's take a look at the next shell script, which is basically in the book. What this does